This brief video is part of a larger series exploring the new NX-Measure command. In this video, I'll show you how to save measurement expressions, measurement annotations, and associative measurement geometry. In this part, we'll do a minimum distance measurement here between this curve on the top and this object set, or this set of curves down below. In this measurement, you can see our minimum distance here is 36.3 millimeters right now. This is the closest approach between this curve and this set down below. And what we're going to do is save that expression using this little save button right here. This will create the associative measurement feature, as it says here, and save that expression. Right next to it is an annotation save. So if this expression is saved, or the feature is created, we can also create the annotation associatively. If we're not saving the expression, we can create the annotation, but it will be non-associative. We need to save the feature in order to preserve any associative results from the measure. So we'll save the feature, that'll create the expression. We'll save the annotation, that'll create a little label and annotation here on the screen at the same time. You may have noticed the little three arrows here. This will actually expand this a little more to some less frequently trafficked functionality here. One of these is creating associative geometry relative to this measurement here. So for this minimum distance, this will create a line in between these two contact points and make that associative. Here again, if we're not saving the feature, then we can create non-associative geometry here if we want to. But we want to create associative geometry, so we'll save that expression. You may note this last one lighting up when we save the expression. If we're saving the expression, we can then create a requirement check against that expression, but we won't do that in this example. So here we'll save the expression, we'll save the annotation, and we'll save the associative geometry of these, and we'll see that here in this feature. So again, this measure feature here, we have an associative expression that's saved. We see the annotation out here on the screen, and the line geometry here actually is also associative. We'll see that work here as we edit the spline. So as we edit the spline data here, move it kind of like this, we'll have a closer approach somewhere on this side now. As we say OK, we'll see that measurement update. Again, our annotation has updated to our new distance here. Our line geometry here has also updated as well. We can do that one more time. Grab that, say, and bring it maybe down to here. That might jump to that lower spot. Yep, sure enough. So there's our new distance, again, our associative geometry there, and our associative expression as well. Okay, so that's a distance example. Here's a example with a different kind of geometry. This one is a counterweight from a crane, for instance. So a large hunk of metal, and we want to find the center of gravity of this. I want to go into wireframe so we can see the inside where the center of gravity will be located. As we do this measurement here, I want to use the solid body here. So I'll select that solid body, and as we do that, again, we get a long list of mass properties that we can choose here. For the center of gravity, again, we can choose to save that center of gravity measurement. We can choose to display an annotation if we want to. I won't do that here. And then create geometry associative to that measurement. This will create a point at that center of gravity relative to this expression right here. Okay. We can also choose, if we want to create principal axes down here. This will create a coordinate system at the principal axes as well. So as we do this here, we'll see that center of gravity point created out there, and you'll notice here that with the NX12 measurement, we're now using a center of gravity marker as the point. We're displaying the point using a CG marker out there. So we can still construct things relative to that point. Again, you see the principal axes now represented also associatively with this coordinate system. So for instance, in this part now, we could come and say, for instance, we need to put a lifting bolt on this particular part so we can lift it straight up. And we'll want to have that bolt be located directly over the center of gravity. To do that, we may put a hole, for instance, up here in the top of this part. Put it up on this plane here, for instance, and as we do that, we want to locate that hole right at that point. Again, that is a point, and you see it, the tooltip described that as a point of that measure feature. So we can choose that point to associatively create that hole right at that hole location. right? That center of gravity location. So we've created that hole that will then stay aligned if we square this up with the top as we change that pocket geometry, right? So as we make this pocket here deeper, that center of gravity will start to move. And so put it into wireframe, we can see the pocket geometry over here. This part has a product template interface on it, so we can see that pocket depth and the resulting mass after we change it. So as we change this pocket depth, for instance, and hit enter here, we'll see that center of gravity location move as we remove material from the part, right? So there we see that move. We can do that again. We'll make a more dramatic move here to 10 inches of depth, so we'll roughly double the depth of the pocket. And again, we'll see the CG move as we do that as well.